So there are two dimensions to multimodality. Two reasons why it is interesting. The first reason is a little bit humble. The first reason is that multimodality is useful. It is useful for a neural network to see. Vision in particular, because the world is very visual. Human beings are very visual animals. I believe that a third of the human cortex is dedicated to vision. And so, by not having vision, the usefulness of our neural networks, though still considerable, is not as big as it could be.
Mm-hmm.
So it is a very simple usefulness argument.
Mm-hmm.
It is simply useful to see. And GPT-4 can see quite well. There is a second reason to do vision, which is that we learn more about the world by learning from images in addition to learning from text. That is also a powerful argument, though it is not as clear-cut as it may seem. And I'll give you an example. Or rather, before giving an example, I'll make the general comment. For a human being, us human beings, we get to hear about 1 billion words in our entire life.
Only?
Only 1 billion words.
That's amazing. Yeah.
That's not a lot.
Yeah, that's not a lot.
So we need to compensate.
Does that include my own words in my own head?
Make it 2 billion words if you want. But you see what I mean.
Yeah.
You know, we can see that because 1 billion seconds is 30 years. So you can kind of see, like, we don't get to see more than a few words a second, and then we are asleep half the time.
Yeah.
So like a couple billion words is the total we get in our entire life.
Mm-hmm.
So it becomes really important for us to get as many sources of information as we can. And we absolutely learn a lot more from vision. The same argument holds true for our neural networks as well, except for the fact that the neural network can learn from so many words. So things which are hard to learn about the world from text in a few billion words may become easier from trillions of words. And I'll give you an example. Consider colors. Surely one needs to see to understand colors. And yet, the text-only neural networks who've never seen a single photon in their entire life, if you ask them which colors are more similar to each other, it will know that red is more similar to orange than to blue.
Mm-hmm. Mm-hmm.
It will know that blue is more similar to purple than to yellow.
Mm-hmm.
How does that happen? And one answer is that information about the world, even the visual information, slowly leaks in through text. But slowly, not as quickly. But when you have a lot of text, you can still learn a lot. Of course, once you also add vision and learning about the world from vision, you will learn additional things which are not captured in text.
Mm-hmm.
But it is not, I would not say that it is a binary. There are things which are impossible to learn from text only.
Mm-hmm.
I think this is more of an exchange rate.
Yeah.
And in particular, as you want to learn, if you are like a human being and you want to learn from 1 billion words or 100 million words, then of course the other sources of information become far more important.
Yeah, and so the you learn from images. Is there a sensibility that would suggest that if we wanted to understand also the construction of the world, as in, you know, the arm is connected to my shoulder, that my elbow is connected, that somehow these things move, the animation of the world, the physics of the world. If I wanted to learn that as well, can I just watch videos and learn that?
Yes.
Yeah. And if I wanted to augment all of that with sound, like for example, if somebody said the meaning of great, great could be great, or great could be great, you know. So one is sarcastic, one is enthusiastic. There are many, many words like that, you know. That's sick, or, you know, I'm sick, or I'm sick. Depending on how people say it, would audio also make a contribution to the learning of the model, and could we put that to good use soon?
Yes.
Yeah.
I think it's definitely the case that, well, what can we say about audio? It's useful. It's an additional source of information. Probably not as much as images or video, but there is a case to be made for the usefulness of audio as well, both on the recognition side and on the production side.
When you on the context of the scores that I saw, the thing that was really interesting was the data that you guys published. Which one of the tests were performed well by GPT-3, and which one of the tests performed substantially better with GPT-4? How did multimodality contribute to those tests, do you think?
Oh, I mean, in a pretty straightforward way. Anytime there was a test where where to understand the problem, you need to look at a diagram. Like, for example, in some math competitions, like there is a math competition for high school students called AMC 12, right? Yeah. And there, presumably, many of the problems have a diagram. So GPT 3.5 does quite badly on that test. GPT 4 with text only does, I don't remember, but it's like maybe from 2% to 20% accuracy of success rate. But then when you add vision, it jumps to 40% success rate. So the vision is really doing a lot of work. The vision is extremely good. And I think being able to reason visually as well and communicate visually will also be very powerful and very nice things, which go beyond just learning about the world. You have several things. You can learn about the world. You can then reason about the world visually. And you can communicate visually. Where now, in the future, perhaps in some future version, if you ask your neural net, hey, like, explain this to me, rather than just producing 4 paragraphs, it will produce, hey, like, here's like a little diagram which clearly conveys to you exactly what you need to know, and so on.
Yeah, that's incredible. One of the things that you said earlier about an AI generating tests to train another AI, there was a paper that was written about, and I don't completely know whether it's factual or not, but that there's a total amount of somewhere between 4 trillion to something like 20 trillion useful, tokens in language tokens that the world will be able to train on, over some period of time, and that we're going to run out of tokens to train. And well, first of all, I wonder if that you feel the same way, and then secondarily, whether the AI generating its own data could be used to train the AI itself, which you could argue is a little circular, but we train our brain with generated data all the time by self-reflection, working through a problem in our brain, or some, I guess neuroscientists suggest sleeping. We do a fair amount of developing our neurons. How do you see this area of synthetic data generation? Is that going to be an important part of the future of training AI and the AI teaching itself?
Well, I think, like, I wouldn't underestimate the data that exists out there. I think there's probably more data than people realize. And as to your second question, certainly a possibility. Remains to be seen.
Yeah. It really does seem that one of these days our AIs are when we're not using it, maybe generating either adversarial content for itself to learn from, or imagine solving problems that it can go off and then improve itself. Tell us whatever you can about where we are now and where do you think we'll be in not too distant future, but pick your horizon, a year or two. Where do you think this whole language model area would be in some of the areas that you're most excited about?
Predictions are hard, and it's a bit, although it's a little difficult to say things which are too specific, I think it's safe to assume that progress will continue, and that we will keep on seeing systems which astound us in the things that they can do. And the current frontiers will be centered around reliability, around the system can be trusted, really get into a point where we can trust what it produces. Really get into a point where if it doesn't understand something, it asks for a clarification, says that it doesn't know something, says that it needs more information. I think those are perhaps the areas where improvement will lead to the biggest impact on the usefulness of those systems. Because right now, that's really what stands in the way. You ask a neural net to maybe summarize some long document, and you get a summary. Like, are you sure that some important detail wasn't omitted? It's still a useful summary, but it's a different story when you know that all the important points have been covered. At some point, and in particular, it's okay, even there is ambiguity, it's fine, but if a point is clearly important, such that anyone else who saw that point would say, this is really important, when the neural network will also recognize that reliably, that's when you know. Same for the guardrail, same for its ability to clearly follow the intent of the user, of its operator. So I think we'll see a lot of that in the next 2 years.
Yeah, that's terrific, because the progress in those two areas will make this technology trusted by people to use and be able to apply for so many things. I was thinking that was going to be the last question, but I did have another one. Sorry about that.
Okay, go for it.
So ChatGPT to GPT-4. GPT-4, when you first started using it, what are some of the skills that it demonstrated that surprised even you?
Well, there were lots of really cool things that it demonstrated, which were quite cool and surprising. It was quite good. So I'll mention two so let's see. I'm just trying to think about the best way to go about it. The short answer is that the level of its reliability was surprising. Where the previous neural networks, if you ask them a question, sometimes they might misunderstand something in a kind of a silly way. Whereas with GPT-4, that stopped happening. Its ability to solve math problems became far greater. It's like you could really really do the derivation and long, complicated derivation, and you could convert the units and so on. And that was really cool. Many people
it works through a proof. It works through a proof. I mean, it's pretty amazing.
Not all proofs, naturally, but quite a few.
Yeah.
Or another example would be, many people noticed that it has the ability to produce poems with, every word starting with the same letter, or every word starting with some...
It follows instructions really, really clearly.
Not perfectly still, but much better than before.
Yeah, really good.
And on the vision side, I really love how it can explain jokes, it can explain memes. You show it a meme and ask it why it's funny, and it will tell you, and it will be correct. The vision part, I think, it's really actually seeing it when you can ask follow-up questions about some complicated image with a complicated diagram and get an explanation. That's really cool. But yeah, overall, I will say, to take a step back, I've been in this business for quite some time, actually, almost exactly 20 years. And the thing which I find most surprising is that it actually works.
Yeah.
It turned out to be the same little thing all along, which is no longer little and is a lot more serious and much more intense. But it's the same neural network, just larger, trained on maybe larger data sets in different ways, with the same fundamental training algorithm.
Yeah.
So it's wow. I would say this is what I find the most surprising.
Yeah.
Whenever I take a step back, I go, how is it possible that those ideas, those conceptual ideas about, the brain has neurons, so maybe artificial neurons are just as good. And so maybe we just need to train them somehow with some learning algorithm, that those arguments turned out to be so incredibly correct. That would be the biggest surprise, I'd say.
In the 10 years that we've known each other, the models that you've trained and the amount of data you've trained from what you did on AlexNet to now is about 1 million times. And no one in the world of computer science would have believed that the amount of computation that was done in that 10 years time would be 1 million times larger, and that you dedicated your career to go do that. You've done many more. Your body of work is incredible, but 2 seminal works, and the co-invention with AlexNet, and that early work, and now with GPT at OpenAI. It is truly remarkable what you've accomplished. It's great to catch up with you again, Ilya, my good friend, and it is quite an amazing moment. And today's talk, the way you break down the problem and describe it, this is one of the best PhD beyond PhD descriptions of the state of the art of large language models. I really appreciate that. It's great to see you. Congratulations.
Thank you so much.
Yeah, thank you.
I had so much fun.
Thank you.